أعزائي طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج ديناميكس. النهاردة إن شاء الله هنستعرض مع بعض موضوع نيوتن second law. Dear students of grade 3 secondary, welcome to our math program. Today we have dynamics. Our lesson today is Newton second law. Newton second law. Rate of change of momentum with respect to the time is proportional to the acting force and takes place in the same direction in which the force is acting. Newton's second law discuss the relation between the momentum and the force acting on the body. What is the mathematical expression of Newton's second law? The rate of change of momentum means dh dt varies as the force acting on the body. What is the momentum h? Is the product of the mass of the body and its velocity. Then the derivative of mv with respect to time t varies as the force F. The force and the velocity is a vectors. Then the derivative of mv equals k times vector F, where k is a constant. We have two cases in Newton's second law. The first case, if the mass m is constant during the motion of the body, then m times dv dt equals kf. V and f are vectors. What is the derivative of v, vector v, with respect to the time t? The derivative of velocity vector with respect to time is the acceleration vector. Then ma vector equals k multiply vector f. K multiply vector f. If both the force F and acceleration a vector are in the same direction, thus we can express them of a unit vector c. C here is a unit vector in their direction by means of their measure as vector f equals f times vector c and vector a equals a times vector c. What is f and a? Where f and a are the algebraic measure of the two vectors f vector and a vector, and they are positive. Then the mass m times acceleration a in direction of c equals k times the force F in the direction c. C is the same direction of the acceleration and the force F, then ma equals k times F. If we choose a unit force such that if it affects on a body of unit mass, it acquires an acceleration of magnitude 1 in its direction, then ma equals kf when the mass equals unit 1 and the acceleration equals 1 equals k times the force equals unit 1, then the constant k equals 1. Now the equation of motion is written in the form ma vector equals vector f or ma equals f, where m is the mass of the moving body, a is the acceleration of motion, and f expresses the algebraic measure of the resultant of the system of forces acting on the body. Then we can say MA equals summation F. The second case, if the mass M is variable, not constant, during the motion, then the equation of motion is written in the form d, the derivative of mv with respect to time, equals vector f. The derivative of m times vector v is the product of two functions. The derivative of the product equals m dv dt vector v plus vector v times dm dt. The right hand side equals vector f. Then if the mass of the body is variable, not constant, then Newton's second law can be written in the form m dv dt plus v dm dt equals the vector f. Now, what is the units of the force? Number one, absolute units. Definition of the Newton. Newton, it is the magnitude of the force which, if it acts on a body of mass 1 kilogram, it acquires an acceleration of magnitude 1 meter per second squared. And we have definition of the dyne. It is the magnitude of the force which, if it acts on a body of mass 1 gram, it acquires an acceleration of magnitude 1 centimeter per second squared. And we note that 1 Newton equals 100,000 dyne, or equals 10 to the power 5 dyne. The second type of units is gravitational units. What is the definition of kilogram weight? It is the magnitude of the force which, if it acts on a body of mass 1 kilogram, it acquires an acceleration of magnitude 9.8 meters per second squared. What is the definition of gram weight? It is the magnitude of the force which, if it acts on a body of mass 1 gram, it acquires an acceleration of magnitude 980 centimeter per second squared. Now, 1 kilogram equals 1 Newton equals 100,000 dyne, or equals 10 to the power 5 dyne. And 1 kilogram weight equals 1,000 gram weight, or equals 10 to the power 3 gram weight. And 1 kilogram weight equals 9.8 Newton. And 1 gram weight equals 980 dyne. Now, if we use the formula MA equals F, then the mass in kilogram and the acceleration in meter per second square, then the force must be in Newton. But if the mass in gram and the acceleration in centimeter per second squared, then the force must be in dyne. Now, let's start with the first example. A force of magnitude 10 newtons acts on a body at rest of mass 8 kilogram to move it in its direction with a uniform acceleration. Calculate the distance traveled after 12 seconds and its velocity. Now we have force equals 10 Newton acts on a body at rest. Then the initial velocity of the body v naught equal 0. And the body of mass 8 kilogram. The body traveled 12 seconds. Then t equals 12 seconds. The equation of motion of the body is F equals ma. F equals 10 Newton equals the mass of the body equals 8 kilogram multiply the acceleration A. Then the acceleration equals 10 over 8 equals 5 over 4 meter per second squared. Then we get the acceleration of the body equals 5 over 4 meter per second squared. What is the distance traveled after 12 seconds? We know that S equals V naught T plus half AT squared. Then S equals V naught times T, 0 times 12 equals 0, plus half times the acceleration A, 5 over 4, times T power 2, 12 power 2. Then S equals 90 meter. Then the body traveled a distance equals 90 meter after 12 seconds. Now, what is the velocity of the body? Since V equal V naught plus AT, then the velocity V equals V naught, which equals 0, plus the acceleration A equals 5 over 4 multiply 12, then the velocity of the body equals 15 meter per second. Then the body traveled a distance equals 90 meter after 12 seconds, and its velocity after 12 seconds is 15 meter per second. Another example. A body of mass 3 kilogram is let to fall from a height of 10 meter on a sandy ground to sink embedded in it for a distance of 5 centimeter. 5. The sand resistance to the body in kilogram weight, given that the body moves with a uniform acceleration within the sand. Now, the phase of free falling. The mass of the body equals 3 kilogram and the initial velocity V naught equal 0 because the body let to fall from a height of 10 meter. Then S equals 10 meter. What is the velocity of the body after it traveled 10 meters? Yes, V squared equal V naught square plus T 2GS. V squared equals 0 plus 2 times G equals 9.8 meter per second squared, and S equals 10 meter. Then V squared equals 196, and the velocity V equals square root of 196, which equals 14 meter per second. Then the body traveled 10 meters and its velocity at the end of the 10 meters equals 14 meter per second. Now the phase of sinking in sand. The mass of the body equals 3 kilogram and the initial velocity V naught equals 14 meter per second. What is the distance in the sand? S equals 5 centimeter, but we use meter units. Then 5 over 100 equals 5, the displacement S equals 5 over 100 meter. Then V power 2 equals V naught power 2 plus 2AS. Note that here in the sand we use acceleration A, but in the free falling we use G, gravity. G equals 9.8 meter per second square, but the acceleration here equals A. What is the value of A? Now, V equals 0. then 0 power 2 equals 0 equals V naught squared, which equals 14 power 2 plus 2 times the acceleration A times the displacement S, which is 0.05. Then 0.1 times A equals negative 196. Then the acceleration A equals negative 1960 meter per second squared. Now, this acceleration is the acceleration of the body during its motion within the sand. What is the equation of motion of the body in the sand? Yes, MA equals mg minus r. MA, the mass times the acceleration, equals the resultant of the forces acting on the body. The body moves in the sand under the action of two forces. The first force, mg, the weight of the body, and it's vertically downward. And the resistance of the sand to the body, which is r, the resistance in the opposite direction of motion of the body. The body moves downward, then the resistance moves upwards or acting upwards. Then MA equals mg minus r is the equation of motion of the body during its motion within the sand. Then the mass equals 3 multiply the acceleration, which equals negative 1960, equals m, the mass of the body, 3 times g, the gravity of the body, equals 9.8 meter per second square, minus r, which is the resistance of the sand to the body. Then the resistance r equals 3 multiply 9.8 plus 3 multiply 1960. Then r equals 5909.4 Newton. This is the resistance of the sand to the body in Newton unit. But what is the resistance in kilogram weight unit? Yes, R equals 5909.4 divided 9.8. Now this unit is kilogram weight. Then the resistance equal 603 kilogram weight. The resistance now in kilogram weight unit. Dear students, now we discuss the relation between the mass and the weight. The weight equals the mass of the body when we use gravitational units, or the weight equals mg when we use absolute units. When we use gram or gram weight or kilogram weight, then the weight equals the mass. But if we use Newton or Dyne, then the weight equals mg. The weight of a body is the Earth's attraction force to the body. If we have a body of mass m equals 1 kilogram, then its weight W, according to the equation of motion, is equal to 1 kilogram weight. And we know that from Newton's second law, F equals ma. F is the weight of the body, then the weight of the body W equals ma. Then W equals 1 multiply 9.8. Then the weight W equals 9.8 Newton, or the weight equals 1 kilogram weight. If the mass is constant and the force is a function of time t, put the acceleration A equals dv dt. Then ma equals F. We can write this formula in the formula m dv dt equals the force F. If the mass is constant and the force is function of time, then the Newton's second law formula, ma equals F, can be written in the form m dv dt equals the force F. And m integration dv from v1 to v2 equals integration f dt from t1 to t2. The second case, if the mass is constant and the force is a function of the displacement s, put acceleration a equals v dv ds, then ma equals F can be written in the form m dv ds equals the force F. And m integration v dv from v1 to v2 equals integration f ds from s1 to s2. If the mass is constant and the force is a function of the velocity v, put the acceleration a equals dv dt, and the formula ma equals F can be written in the form m dv dt equals F. Then m integration 1 over F dv from v1 to v2 equals integration dt from t1 to t2. Now we have three cases. If the force is a function of time, then m integration v1 to v2 dv equals integration f dt from t1 to t2. And if the force is a function in displacement s, then m integration v dv from v1 to v2 equals integration f ds from s1 to s2. And if the mass is a constant and the velocity, the function of the velocity f, the force is a function of the velocity v, then m integration 1 over f dv from v1 to v2 equals integration dt from t1 to t2. The equation of motion of a body is ma equals F. Note that ma equals. What is the meaning of F? F means the sum of forces in the direction of motion minus sum of forces in the opposite direction of motion. Then ma equals F means m, the mass of the body, multiplies the acceleration a equals F. F here, the resultant of the forces acting on the body. But we know that F equals sum of forces in the direction of motion minus the sum of forces in the opposite direction of the motion. Example, a force F acts on a body from the origin point, and a force F equals 5x plus 6 act on the body to move it. This force in terms of x, the displacement of the body with respect to the origin point, or the distance between the body and the origin point. And we know that ma equals F from Newton's second law. Then ma equals 5x plus 6. Now we have a relation between the mass and the acceleration of a body and the distance between the body and the origin point. We know that the acceleration a equals dv dx, and the mass of the body equals 1 kilogram. Then m times a equals 1 times v dv dx equals the force F, which equals 5x plus 6. Now, integration of v dv from v naught to v equals integration 5x plus 6 dx from 0 to 4. The acceleration of the velocity v equals half v power 2 from 0 to v. And the integration of 5x plus 6 is 5 over 2 x power 2 plus 6x from 0 to 4. Now, the left hand side equals half v power 2 minus half times 0 power 2, which equals 0. And the right hand side equals 5 over 2 times 4 power 2 plus 6 times 4 minus 5 over 2 times 0 minus 6 times 0, which equals 0. Then half v power 2 equal 64. Multiply both sides by 2, then v power 2 equals 128, then the velocity equal positive or negative square root of 128, then the velocity equals positive or negative 8 root 2 meter per second. Dear students of grade 3 secondary, by these examples we come to the end of our program today, and till we meet again, it's goodbye.